Whew. Hey guys, long time no see. How you guys been? Yeah, it's been a while. But hey, I'm back. Just been like school and stuff going on. So anyway, anyhow, let's get into today's reaction video. Today we're going to be watching string theory, video string theory by Kuzgazart. So let's just jump right into it, guys. Good to see you again, by the way. So let's just jump right into it. I'm gonna
What is the true nature of the universe? To answer this question, humans come up with stories to describe the world. We test our stories and learn what to keep and what to throw away. But the more we learn, the more complicated and weird our stories become. Some of them so much so that it's really hard to know what they're actually about. Like string theory, a famous, controversial and often misunderstood story about the nature of everything. Why did we come up with it, and is it correct, or just an idea we should chuck out?
I missed this. Yeah. Oh.
To understand the true nature of reality, we looked at things up close and were amazed. Wondrous landscapes in the dust, zoos of bizarre creatures, complex protein robots, all of them made from structures of molecules made up of countless, even smaller things, atoms. We thought they were the final layer of reality until we smashed them together really hard and discovered things that can't be divided anymore, elementary particles. But now we had a problem. They're so small that we could no longer look at them. Think about it. What is seeing? To see something, we need light, an electromagnetic wave. This wave hits the surface of the thing and gets reflected back from it into your eye. The wave carries information from the object that your brain uses to create an image.
That sounded was kind of crazy.
When you write, your tone influences how readers respond. With Grammarly, just highlight your text and type how you want to sound.
It really has been a while, guys.
So you can't see something without somehow interacting with it. Seeing is touching, an active process, not a passive one. This is not a problem with most things. But particles are very, very, very small. So small that the electromagnetic waves we use to see are too big to touch them. Visible light just passes over them. We can try to solve this by creating electromagnetic waves with more and much smaller wavelengths. But in quantum physics, shorter wavelengths means more energy. So when we touch a particle with a wave that has a lot of energy, it gets a kick. By looking at a particle, we change it. In quantum physics, we cannot know where a particle is and where it's going with absolute precision.
That's interesting. So they're too small for us to see, and just for us to be able to see it, it changes. Like, and that kind of like plays into some other ideas too about like how things change based on if we are observing it or not. So, like, maybe there is something to those ideas.
Fact is so important that it has a name. The Heisenberg uncertainty principle, the basis of all quantum physics. So what does a particle look like then? What is its nature? We don't know. If we look really hard, we can see a blurry sphere of influence, but not the particles themselves. We just know they exist. But if that's the case, how can we do any science with them? We did what humans do and invented a new story, a mathematical fiction. The story of the point particle. We decided that we would pretend that a particle is a point in space. Any electron is a point with a certain electric charge and a certain...
That's kind of like the same thing we did with dark matter. We just knew that, oh, there's something out there in space. We don't know exactly what it is and exactly what it does or where it came from. So we just call it dark matter because it is matter. It's occupying space as the definition of matter is, but we don't know what it is. So it's unknown. We're in the dark about that. So, we figured it out, guys.
mass, all indistinguishable from each other. This way, physicists could define them and calculate all of their interactions. This can be made precise in quantum field theory, and this solved a lot of problems. All of the standard model of particle physics is built on it, and it predicts lots of things very well. Some quantum properties of the electron, for example, have been tested and are accurate up to 0.000000000002%. So while particles are not really points, by treating them as if they were, we get a pretty good picture of the universe. Not only did this idea advance science, it also led to a lot of real-world technology we use every day. But there's a huge problem: gravity. In quantum mechanics, all physical forces are carried by certain particles. But according to Einstein's general relativity, gravity is not a force like the others in the universe. If the universe is a play, particles are the actors, but gravity is the stage. To put it simply, gravity is a theory of geometry, the geometry of space-time itself, of distances which we need to describe with absolute precision. But since there is no way to precisely measure things in the quantum world, our story of gravity doesn't work with our story of quantum physics. When physicists tried to add gravity to the story by inventing a new particle, their mathematics broke down. And this is a big problem. If we could marry gravity to quantum physics and the Standard Model, we would have the theory of everything. So, very smart people came up with a new story. They asked, what is more complex than a point? A line or a string? String theory was born. What makes string theory so elegant is that it describes many different elementary particles as different modes of vibration of the string. Just like a violin string vibrating differently can give you a lot of different notes, a string can give you different particles. Most importantly, this includes gravity. String theory promised to unify all fundamental forces of the universe. This caused enormous excitement and hype. String theory quickly graduated to a possible theory of everything. Unfortunately, string theory comes with a lot of strings attached. Much of the maths involving a consistent string theory does not work in our universe with its 3 spatial and 1 temporal dimensions. String theory requires 10 dimensions to work out. So string theorists did calculations in model universes, and then tried to get rid of the 6 additional dimensions and describe our own universe. But so far, nobody has succeeded, and no prediction of string
Wait. What's going on here? I'm going to try and paraphrase what they said to see if it makes sense, because it doesn't make sense to me. I'm still so confused. Okay, so string theory, basically trying to find out what the thing that makes up everything is made of, but we don't know what it looks like. We don't know, we have no way of seeing it. We just have a general idea that it exists, right? So we're trying to find out the theory of that thing, like that thing. So the same thing we did with dark matter, as I mentioned earlier, we kind of did the same thing with string theory. We're like, okay, we don't know exactly what it is, but we know that something is there. So let's just assume what is there is this. And then if it is this, does it work with this, and that? So the idea we came up with doesn't work. It doesn't make sense in our own universe. So we're pretty much like in our own like 3-dimensional universe of I see this and it's a 3-dimensional universe, right? So we are creating a universe that has 10 hypothetical dimensions, and we're trying to find a way for string theory to make sense in that 10 dimensions, and then kind of like whittle it away and do some like complicated algebra of let x equals y at the end of the day. So we're trying to find a way to eliminate the extra dimensions till we get to something like the way our dimension works. And we'll not be able to figure it out yet. I don't know. I feel like it sounds so smart and so dumb at the same time. It's kind of like my first impression on like when I first had that, oh, this person discovered gravity. I'm like, I mean, the definition definitely was important, and actually like conceptualizing the idea of gravity as a universal concept and how like the sun and moon rotate and everything. I'm sure it's like they play a very crucial role in our technological development as a species. However, I don't, I don't think it was like, I don't know. I find it difficult to understand why that was like such a jaw-dropping discovery when they realized that what goes up must come down. It's like, we kind of knew that. We just didn't know how far that idea went. I guess that's where the importance comes from. So with the string theory also, as incomprehensible as it is to me right now, it's apparently been useful in coming up with like other technology and trains and those kind of thing, even though we really don't know what it is. So let's keep diving down this rabbit hole. Let's see where it goes.
Theory has been proven in an experiment. So string theory did not reveal the nature of our universe. One could argue that in this case, string theory really isn't useful at all. Science is all about experiments and predictions. If we can't do those, why should we bother with strings? It really is all about how we use it.
It strikes me like, when I see videos like this, it strikes me like science is like a religion on its own. Because when I think about it, most religions are ways people conceptualize the world and how the world works, right? The natural laws and the way things are, not the natural order of things, basically, in different ideas and in different cultures. And the religion is kind of like, bringing the universe to us in a way that we can understand it and operate in, right? And the religions differ and don't seem like ridiculous, but they have a fundamental message or utility that they serve in how human beings function, both individually and as a group. So here comes science now, and a lot of people want to pick up science as the end all and be all of reasoning and logical consistency. But the more you find out, the less logical consistency you find. And it's basically a lot of observations and hypotheses that make sense. And we decided if it makes sense, then we'll just adopt that as the truth because we've pushed the idea and we decided that this makes sense. And this is the only way that we can explain it based on our already established beliefs that we already concluded on, because those ones also made sense. So if all those things we assumed were true are true, and it functions with the other things that we are currently assuming is true, and it works most of the time as that, then it's a logical fact and a scientific principle. And it's basically the same thing with religion. It's like, okay, this is the way life is. This is the origin. This is how it starts. And, if we believe that this is true and this is how the cosmos work and the natural order of things function and the way things start and the way things are destined to end, we already agreed that is true. So these other things are also true. So, that's also a fact. And we should believe it. And the same way people stick to their religious beliefs because it's like a core part of who they are and how they perceive themselves and the world. The same thing is what science is offering. So even when you find yourself in a situation where you believe that science is the pinnacle of human reasoning, and every day those kind of things, you are kind of in the same boat as people who are really devout in their religions, because that's also basically what they believe. And if some of these videos that I needed to go by, neither of them could be proven 100% beyond the shadow of a doubt. At some point you just have to accept the axioms or assumptions they start from as truth. I don't know if any of that even made sense. I just went on a whole rant right there. But you guys know what I'm trying to say, kinda. Hopefully, ask me questions in the comment section. Thank you. Now let's keep going.
Physics is based on maths. 2 plus 2 makes 4. This is true no matter how you feel about it. And the maths in string theory does work out. That's why string...
Even the... I'm not going to go into a whole deep dive rant about this, but even the notion that 2 plus 2 is 4 and 2 plus 2 is always 4, I think, like people of the more religious persuasion have like firm foot to stand on, that this supports their belief that of a supreme being controlling everything, because it doesn't seem like the world is just full of chaos and things are happening randomly. Like most of the things in our solar system are like clockwork, to the extent that we can predict what the stars used to look like and what they will look like in the future. Like we can predict what the weather is like, and with global warming, it's like things that are consistent. 2 plus 2 is 4, and 2 plus 2 is always 4, except if you are doing some kind of like advanced mathematics that I don't know. But 2 plus 2 is gonna be 4. What goes up will come down. It's not like 2 plus 2 is 4 sometimes, but on Tuesdays it's like 5 or 14. The things function in a specific way, and we are like scrambling to find the correct definition or the correct way it actually works. And so far we still don't know what we're doing, man. I said I wasn't gonna go into a rant, but another rant. And like, there's an argument to be made that when you look at the advancements in technology that has come from science and following this like logical procedure, like it's look like the steam engine and all those kind of things, like those are like noteworthy things that we've been able to accomplish, but I don't think they negate or they are valid, except if you are trying to use it to invalidate like religious beliefs as a practical or reasonable let's say principle to adopt for life, right? Or like a worldview. So like when we look at like monuments that are built for like religious purposes, or like things people used to like read the stars, they all kind of come from a core religious foundation that is like, okay, this world is working, and it has been working and seems to keep on working in the same way. So now let's try and figure out what those principles are, and we go about it trying to figure out how things work in the physical, how things work in the metaphysical, spiritual, and we extrapolate general themes of life, and we try to pass that on from generation to generation and keep building on it.
Theory is still useful. Imagine that you want to build a cruise ship, but you only have blueprints for a small rowing boat. There are plenty of differences: the engine, the materials, the scale. But both things are fundamentally the same, things that float. So by studying the rowing boat blueprints, you might still learn something about how to build a cruise ship eventually. With string theory, we can try to answer some questions about quantum gravity that have been puzzling physicists for decades, such as how black holes work or the information paradox. String theory may point us in the right direction. When used in this spirit, string theory becomes a precious tool.
I wonder what the information paradox is. We should look into that in a separate video, of course.
For theoretical physicists, and help them discover new aspects of the quantum world and some beautiful mathematics. So maybe the story of string theory is not the theory of everything. But just like the story of the point particle, it may be an extremely useful story. We don't yet know what the true nature of reality is, but we'll keep coming up with stories to try and find out until one day, hopefully, we do know.
I really love that. That's kind of poetic, and it's kind of like what I was saying. It's like it, we still don't really know anything, but we're just gonna keep on coming up with things until we do know. And we, spoiler alert, we never really will know everything. I don't think it's possible for us to really know anything. I have a religious bias, guys. So I am more inclined to have a spiritual explanation for how things occur, and I kind of like frame the world within my own religious beliefs because it makes sense to me, and it kind of like gives me like a compass of sorts to like when I'm interpreting information. So I kind of have that bias when I'm thinking or or like looking at anything in particular. So just putting in that out there so you guys can take that for however you see that. But I think in each generation since the dawn of time, we find information, we find out information and ways of looking at the world that works for us. When we weren't so populous on the planet, simple things like how to farm, making fire, those kind of things worked for us, and that is what we needed. And we found ways to do that and survive, right? And for explaining the moon and the sun and the tides and everything, we also had our own stories about that we believed to be true, and the things we didn't have um, uh, answers to. We just accepted them as like, the great mysteries of life, that we'll find out maybe in the afterlife and things like that. So we had a lot of things like that that were functional and served as the basis of civilization as we know it today. So now we are at a point where we're inventing new ways of being more productive because we have more people, and for us to sustain ourselves, we have to be more innovative in how we cater for ourselves and without like obliterating the lands we live in, right? But who's to say, like, I don't know, 50 years from now, like our whole conceptualization of science might be more spiritual than it is not. I'm just saying, like, it might not be just like, I'm not gonna go. I'm not gonna go into it. I just finished the video. I'm rambling. All right.
This video was supported by the Swiss National Science Foundation and realized with the scientific advice of Alessandro Sfondrini.
Shout out to them. Support them on Patreon. This is an awesome video. I always like this Kuzgazart videos because they really like get me thinking and get me talking. So yeah, that was really good. To see you guys in the next one. Deuces.